Welcome to our channel. In this lesson, I would like us to discuss chemistry, Form 4, topic radioactivity. In this lesson, you need to know definition of radioactivity, definition of nuclide, factors that affect stability of a nuclide, definition of radioactive substance, isotope, radioisotope, and radioactive decay. Types of radioactivity, differences between nuclear reaction and chemical reaction. Now, to start with the definition of radioactivity, radioactivity is a process where unstable nuclide breaks up to yield another nuclide of different composition with emission of particles and energy. What is a nuclide? A nuclide is a particular nucleus that is characterized by both protons and neutrons. Usually, nuclide is represented by atomic number and mass number. Mass number, we also call it atomic mass. This is how a nuclide is represented. So the superscript, which is A, represents the mass number, while the subscript B represents atomic number. From there, you need to know factors that affect stability of a nuclide. Mainly, there are three factors. Factor number one, neutron to proton ratio. If the neutron to proton ratio is equal to 1, then the nuclide is stable. Therefore, it will not undergo radioactive decay. But if the neutron to proton ratio is less than or greater than 1, then it means now that the nuclide is unstable. Therefore, it is likely to undergo a radioactive decay. Now, factor number 2 is mass excess. If the mass of the nuclide is excess, then it means that the nuclide is unstable. Therefore, it is likely to undergo radioactive decay. Then that factor is amount of energy released. If the amount of energy released is high, then that nuclide is going to undergo radioactive decay. Now we need to know definition of radioactive substance. This is a substance that undergo radioactivity. Isotopes are atoms of the same element, same atomic number, but different mass number. And what brings the difference in mass number is the number of neutrons. Radioisotope, this is an isotope which is radioactive in nature. Radioactive decay is the spontaneous disintegration of radioactive nuclide. From there, we need to know types of radioactivity. Mainly, there are two types of radioactivity. Number one, you have natural radioactivity. It usually occurs when a radioactive nuclide breaks spontaneously in nature, yielding a new nuclide with emission of particles and energy. Now, artificial radioactivity, it occurs when a large stable nuclide are bombarded with fast-moving high-energy particles, and in the process, the nuclide splits into relatively smaller particles with emission of particles and energy. Now, you need to know that radioactivity is a nuclear reaction and not a chemical reaction. Therefore, from there, we need to know the differences between nuclear reaction and chemical reaction. Nuclear reaction takes place within the nucleus, while chemical reaction takes place in the energy level. Number two, nuclear reaction involves both protons and neutrons, while chemical reaction involves electrons. Number three, nuclear reaction releases a large amount of heat energy, while chemical reaction releases a less amount of heat energy. Nuclear reaction is not affected by environmental factors such as temperature, while chemical reaction is affected by environmental factors such as temperature. Thank you. That is the end of our lesson for today. For more videos, subscribe to our channel.